So now that we've talked about how to conduct a hypothesis test with a large sample and we're interested in the mean, I also want to talk about what we need to think about when we may not have a large sample and we've got a pretty small sample. We still need to assume that we have random sampling. We still need to have quantitative data. The main thing that's different is now we have to assume that the population is normally distributed. The same types of hypothesis tests will still hold. If we're interested in conducting a two-sided test, we'll express it such that the null is mu equal to whatever mu naught is. Maybe we have an idea of mu naught being equal to 12 and we want to test that. That's still going to be a two-sided test. Now, the way in which we calculate our test statistic is also going to be a little different because no longer are we going to be referencing the normal distribution. We're going to be referencing the t-distribution, which you'll remember has fatter tails, and that requires that you remember the degrees of freedom is calculated differently. Just as before, though, this is going to come from the sampling distribution of whatever your point estimate of interest is. In this case, we're talking still about the mean, so y bar. And importantly, we'll be referencing the t-table rather than the z-table. I've kind of alluded to the reason, but I want you to take a second to think about why that is. And the reason for this is as we increase the number of observations, the t-distribution is going to approximate a normal distribution, which is associated with a z-table. Fourth, we can calculate our p-value. Now, there isn't going to be anything different with regard to calculating the p-value. If you're doing a two-sided test, then you're going to want to have the absolute value of that t-statistic and then multiply it by the probability of the t-statistic being greater than or equal to the one that you observed. And I really want to stress that you want to make sure that you're using the right degrees of freedom, because if you have lower sample sizes, the reason why you're using the t distribution and a t-statistic in the first place, you may mess things up severely. Also remember whether or not you're running a one or a two-sided test, which sounds easier than it is, but this will definitely mess up your calculations because you want to find the probability in the correct direction. The way in which you're going to go about doing this in R is rather than using p-norm, which references the probability distribution of the normal distribution, we're going to reference the probability distribution for the student t distribution. Once we have our p-value, we can actually make a conclusion and an interpretation. If the p-value is below our critical threshold, typically of 0.05, we can say that the evidence suggests that we can reject the null hypothesis and the evidence favors the alternative. But I think what's important here is always provide the p-value and always provide the test statistic. Before moving on, I want to talk about an example. In this case, we're going to be talking about state spending on education. Our theory being that states aren't spending 5% of their income on education. Now, think to yourself what kind of hypothesis test we're going to run before I move forward with the information. So if we're interested in whether states are not spending a given amount, in this case 5%, and we know that we observe state spending 4.7 with a standard error of 0.0922, we can calculate our test statistic as, and I'll give you a second to think about it, 4.7 minus what our expectation is, so mu naught is 5%, over our standard error, which equals negative 2.279 as our test statistic. Now, This is a little more meaningless to me because it's not referencing a normal distribution, but we've got our degrees of freedom here at 49, so we can calculate our p-value using R. Notice here that we're running a two-tailed test. Why is that? It's because we're interested in whether or not they're spending exactly 5%, not above or below. So we're interested in seeing how much mass is in that probability distribution above and below the number of standard deviations or the test statistic away from the expectation. And since that is 0.02, we can confidently say that we find evidence to reject the null hypothesis that states are spending 5% of their income